In this lesson, we're going to review the internal rate of return, that is the IRR formula. The IRR formula is used to determine the discount rate, which makes the net present value of an investment equal to 0. If you calculate the IRR and it's greater than your expected rate of return, i.e. the discount rate, then you should accept the project as an investment. Higher IRR projects have higher growth potential. Let's take a look at the formula in greater detail. First, we have the rate, and in the IRR calculation, the discount rate is not known, and that's the variable that we're trying to solve for. The value is the amount of cash flows that will be returned by the investment. Recall that the net present value formula is as follows. NPV is equal to the negative amount of cash outflow plus the sum of the discounted future cash flows. And the sum of the future discounted cash flows is equal to, for year 1, it would be the cash inflow for year 1 divided by 1 plus the discount rate. And then you'd add year 2, which is the cash inflow for year 2 divided by 1 plus the discount rate. And you'd keep going year after year for the life of the project. The IRR formula is similar to the NPV formula, except the NPV is replaced with a 0 and the rate of return is unknown and replaced with the IRR variable to find. Therefore, 0 equals the negative amount of initial cash outflow plus the sum of the discounted future cash flows. A couple other important notes are as follows. In the case of calculating the NPV, the discount rate is known, and it is considered the expected return on investment. Conversely, in the case of calculating the IRR, the discount rate to make NPV 0 is not initially known. That is the value that we are seeking to understand. Once we have it, we can compare that discount rate to the NPV discount rate. If it's higher than the acceptable rate of return, then it's a good investment decision. So again, we want to calculate what the internal rate of return is, and if it's higher than our acceptable rate of return, then we're going to pursue the investment and consider it to be a good investment decision. If a project is undertaken and the IRR is equal to the company's cost of capital, then it means the present value of the future cash flows for the project is only going to cover the cost of capital and no accretion is going to be given to the shareholder. Therefore, IRR must be higher than the cost of capital in order for a project to be worth any value to shareholders. For example, if a company has a weighted average cost of capital of 8% and the IRR is 7%, the project showing a potential IRR of 7% should be declined because it would cost the company more money through its debt and equity financing than it would yield benefit. The IRR formula can be calculated in Excel using the XIRR formula. XIRR is more accurate than the IRR function in Excel. IRR in Excel considers all time periods equal, whereas the XIRR allows for specific dates to be used. So let's take a look at the XIRR formula. In Excel, XIRR is used as follows. We put X equals XIRR, and then we have the following fields. As syntax, values, dates, and guess. Values is the amount of cash flows returned on the investment. Dates are the dates that the cash flows will be realized. And guess is an optional field, which means the assumption of users about the possible internal rate of return. Let's take a look at an example. In our example, assume upfront investment on a project is $100 and the return in year 1 is $120. The company's cost of capital is 8%. What is the NPV and the IRR? So let's take a look at the solution. The NPV would be equal to the negative amount of the future cash outflow, i.e. on initial investment in the project, it's going to cost $100, plus the sum of the discounted future cash flows. So the discounted future cash flows is equal to 120 divided by 1 plus 8%, which is the cost of capital. So when we do that, we take negative 100 plus 120 divided by 1.08, and that returns a result of $11. Let's take a look at how we calculate the IRR. If we were to do a manual calculation of the IRR, we would want to set the NPV equal to 0, and then we put negative 100 for the upfront cost plus 120 divided by 1 plus R. We're trying to solve for R. We can back into the R as follows. We move the formula around to solve for R, and as we solve for R, R is equal to 1 divided by 0.833 minus 1. And therefore, R is equal to 20%. So in this case, we know that the IRR is equal to 20%, the net present value is equal to $11, and the company's cost of capital is 8%. If we were to use Excel to calculate the IRR instead of doing it manually, then we can use the XIRR formula as shown in cell F49. We put equals XIRR, open parentheses, we highlight the future cash flows of negative $100, which is the upfront investment, as well as 120, which is the future cash inflows. Then we highlight the two dates, i.e. the start date and the end date, the start date being January 1st, 2019, and the end date being 1 year later, since this is a 1-year project, on January 1st, 2020. We press enter and it yields a result of 20%. So the IRR is 20% and the cost of capital is only 8%. As a result, this would be a worthwhile investment for the company to make since IRR is greater than the cost of capital. Let's take a look at another example. In example number 2, the upfront investment on a project is $120,000. The company's weighted average cost of capital is 8%. The timing of future cash flows is in the table below. The question is whether the company should accept the project. So we've got the month and the amount of future undiscounted cash flows located in cells C65 through D79. It's going to cost the company $120,000 up front. They're going to yield a return of $10,000 on an undiscounted basis per year for the next several years. And if we wanted to calculate the IRR, we can see that calculation in cell D83. Again, we only want to accept this project if the IRR is greater than the company's weighted average cost of capital. In this case, we can see the IRR is equal to 7.53%. The discount rate for the company is 8%, and therefore it is less than the discount rate, and it would not have any accretion to the value for shareholders. It would be a waste of time. Therefore, this project should be declined. We can take a look at the formula for XIRR. It's equal to XIRR, open parentheses. We take the sum of the future cash flows, which is cells D66 through D78. We highlight the cells C66 through C78, which is the dates column. We press enter, and that gets 7.53%. We can also see in this calculation that the net cash flow between the first year and over the life of the project is $81,000. They start with an investment of $120,000. The project brings in $201,000 of cash flow. The net amount of those two is $81,000. But on a discounted basis, the NPV is not $81,000. It's only $3,370. And we know that by using the NPV formula in Excel. We can use the NPV formula as follows. We put in equals NPV, we put in the rate, which is the company's discount rate of 8% cost of borrowing. Then we put in the values, i.e. cells D67 through D78. That's the future cash inflows. And then we add the upfront cost, which is a negative value. And when we do that, we can see that the project would actually lose money. It would only have a yield of negative $3,370. So this project is not worthwhile. It should not be pursued. This is a good example that shows that you need to take into consideration the time value of money. At face value, it seems like this may be a profitable and lucrative investment because the net cash flow is $81,000. But when you consider the cost of capital, it's actually a negative NPV and the IRR is less than the cost of capital. Let's take a look at a third example. In the third example, Apple Branch & Co. made two investments named Zebra and Exacto. The owners of the company want to find out which investment provided them more return. The cash flows along with dates of return are given in the below table. So we've got the particulars, whether it's an investment or cash inflow in column C. We've got the investment date in column D, the cash flows in column E, the investment date for Exacto in column F, and the cash flows for Exacto in column G. So we can calculate the NPV as follows. NPV of the Zebra investment is $18.50. NPV of the Exacto project is $810. And for IRR, we can perform the calculation in cells D107 and D108. So to do that, we highlight the cells of the values, so E94 through E99, which is where all of the values are located, and then we put in the dates in cells D94 through D99. That gives us with an XIRR of 16.57%. For investment 2, it ends up being 1.26%. Again, we apply the same formula, but we select columns F and G for the Exacto dates and discounted cash flows. Let's take a look at example number 4. In example number 4, a company is considering two mutually exclusive investment options, option A and option B. The cash flows for each are as follows. We've got a table which indicates the year, whether it's a cash outflow or inflow. We've got the two option dollar amounts of what's going to be generated over the life of the investment by year. So option A costs $10,200 upfront, option B costs $35,250 upfront, and they have different cash flow yields per year. The question is, which option will be preferred by using the IRR as the basis of decision making? So we can use the manual method in order to calculate the IRR. For the first option of investment, the total receipts were $14,000, so the $6,000, $5,000, and $3,000. Now the total upfront cost is $10,200, so that provides a total profit of approximately $3,800 and an average profit per year of $1,267. The average investment, i.e. opening plus closing divided by 2, is $5,100. The average return, therefore, is $1,267 divided by $5,100 equals 25%. We can take 2/3 of ARR for the initial estimation of the IRR. That will be approximately 17%. If we take 2/3 of the 25%, we get 17%. So we can originally just estimate the IRR. Then in our table, we can calculate the NPV as follows. We take the future cash outflows and inflows for each of the projects. And let's start with option A. So cell D138 shows the cash outflow for the first project, and D139 through D141 shows the cash inflows. So $6,000, $5,000, and $3,000 by year 3. The discount factor, we're going to assume 17%, and therefore the present value of future cash flows is represented in column F. Let's try this again by using a discount factor of 22%, because again, remember that we're trying to find the IRR, and the IRR is the percentage that makes the net present value of future cash flows equal to 0. In this case, in our first example, it was $454. So we're going to try to get it closer to 0. When we use 22%, we get negative $271. And therefore, because this is negative and the other calculation using 17% was positive, we believe that it's somewhere in between that will yield a $0 NPV. And we can find that as follows. We can put in 17% plus 454, which is the sum of the discounted future cash flows, divided by the sum of the discounted cash flows at 17% and 22%, and then we multiply that by the difference between the 22% and the 17%. So you can copy this formula to reuse. I've also put it in row 146, but when we do that, it tells us that the IRR to make NPV equal to 0 is 20%. In option B, we're able to see that the total receipts are $48,000, i.e. 18,000 plus 15 plus 15, and that gives a total profit of $12,750 in the project because the initial investment is $35,250. The average profit is $4,250 over the years, and the average investment is $16,000. The ARR is the $4,250 divided by $16,000, and that's 27%. We can take 2/3 of the ARR for an initial estimate of the IRR, and that will be approximately 18%. When we use the 18% as the discount factor in our NPV formula, we get $458 for 17% and negative 94 for 18%. If we were to plug that into the same formula like we did before, we can find that the IRR is 18%. Therefore, option A is a more profitable option because it has a higher IRR compared to option B. The IRR for option A was 20% and the IRR for option B is 18%, so we should go with option A. Let's take a look at a fifth example. In our example, Hazard Group is considering a proposal to purchase and install a new machine at a cost of $50,000. The machine has a life expectancy of 5 years and has no salvage value. The company's tax rate is 35%. Assume the company uses straight-line depreciation and the same is allowed for tax purposes. The estimated profit before depreciation and before tax from the investment proposal are as follows. As you can see, in year 1, it starts at $10,000 of cash flows, and by year 5, it reaches $20,385. The company's weighted average cost of capital is 6%, and the company would like to make an investment decision using IRR. The calculation of the profit after tax is outlined in the table starting in row 190. So we have the profit before tax, we have depreciation, profit after depreciation, and then we have the tax rate at 35%. So the profit after tax is located in column H. So again, the company wants to make an investment decision using IRR. We know the cost of capital is 6%. And in the final table of this spreadsheet, you can see starting in row 200, we've got our calculations for IRR. It turns out that the IRR is 8%, and therefore this investment should be accepted and pursued because it is accretive to shareholder value. Well, we've got in this table here years 1 through 5 profit before depreciation and tax, depreciation, profit after depreciation, tax, and profit after tax. So to go through one example, in year 5, the profit before depreciation and tax is $20,385. Depreciation is $8,000, and the profit after depreciation is $12,385. Tax is at 35%, so $4,335, and the profit after tax is $8,050. If we were to add up all 5 years, we get $18,400. And to calculate the IRR, we take the negative $50,000 of cash outflow. We can see that cell F204 is the sum of the profit before depreciation plus the add back of depreciation to bring it to $84.50. The IRR is calculated in cell F208 and it's equal to XIRR open parentheses. Then we select cells 202 through 207 in column F, which is the value of future cash flows, and we highlight cells 202 through 207 in column C, which is the year column and date column. When we do that and we press enter, the IRR is 8%. Since that is higher than 6%, this investment should be pursued. Hey guys, thanks for watching this lesson. I hope you enjoyed it. And if you did, I'd really appreciate a like and subscribe from you. And if you want to learn more about Microsoft Excel, check out these videos above. And don't forget to check out our website, commercecurve.com, where we have lots of in-depth finance and accounting courses available with full training workbooks. All of our courses come with complete workbooks of lessons, examples, pre-built financial models, and training video. Hope to see you there.